All right, people, welcome to Unit 3. So right here, we are on Unit 3. We're on the notes for assignment number 1. You should already have the probability as an area model filled out. So what we're going to do is we're going to fill out the angle relationships portion and the similar figures and solving proportions portion of the note. So first of all, alternate interior angles. Okay, so let's say that I have two lines that are parallel to one another, such as this right here. Not the greatest drawing in the world. And we know that these lines are parallel given by the arrows that we have. And it could be one arrow or it could be two arrows. It doesn't matter, but if you see the same number of arrows like I just drew in red right there, that would mean that those two lines are parallel. And then let's say that I have a line going through those parallel lines. That line right there is what is known as a transversal. So a transversal is any line that intersects two other lines. Okay? And when I drew in that transversal, I created 8 distinct angles, and I am identifying the 8 distinct angles by using the variables a through H. So we've got angle A, B, C, D, angle E, F, G, H. Okay. Now, alternate interior angles, these are a relationship of angles that always come in pairs. Okay. And in order for the angles to be alternate interior, the two angles have to be on the alternate sides of the transversal. So they have to be on alternate sides of the transversal. So that means like A and F or D and E. Okay. But they have to be on the interior portion of the diagram. And the interior portion of the diagram would be everything in between the two parallel lines. So everything in the blue. Okay, so for angles to be alternate interior in this picture, they would have to be on alternate sides of the transversal, and they would have to be in the blue part, the interior picture. So there are two pairs here. An example would be angle C is an alternate interior angle with angle F. Okay, and another pair would be angle D, which you can see is on the right side of the transversal, would be an alternate interior pair of angles with angle E, which is on the left side of the transversal. Okay, so in this picture, alternate interior angles would be angle C and angle F, and angle D and angle E. Okay, now, there is a rule about alternate interior angles. So, the rule is this. When lines are parallel, then alternate interior angles are congruent with each other. Okay? So whenever you have parallel lines, that means the alternate interior angles are congruent with each other. So let's say that angle C is equal to the algebraic expression 5x minus 8 degrees. And let's say angle F is equal to just the expression, we don't even have to make it, or is equal to the number 100. Let's not make it 100 because angle F is a acute angle. So let's make it equal to 72 degrees. So let's say angle F is equal to 72 degrees. Okay, now watch what I can do. I could now set up an equation and solve for x here. And what I could be doing, I'm using the fact that when lines are parallel, I have parallel lines, alternate interior angles are congruent with each other. Okay, so that means that angle C is going to be congruent with angle F. Okay, angle C is represented by the algebraic expression 5x minus 8. Angle F is represented or is 72 degrees. So to solve for x, I create the equation 5x minus 8 is equal to 72. And then I use algebra to solve. Add 8 to both sides. I'm going to work my rest of my problem out here. That would make my equation 5x is equal to 80. And then I would divide 80 by 5 and 5 by 5 to cancel out the 5s. And x would be equal to 16. Okay, so we could use alternate interior angles to help us out to solve for an equation like x. Okay, now let's go to the other angle relationship, and that would be supplementary angles with a transversal. So in this picture right here, we're going to have parallel lines just like we had in the previous picture. Okay, and then we're going to have a transversal, just like we had in the previous picture. Okay, so we've got these parallel lines, as indicated by these arrows, and then we've got a transversal here, and then, as in the previous problem, when I drew in the transversal, I created 8 distinct angles, and I'm going to signify them with the variables A, B, C, D, E, F, G, and H. Okay, now, supplementary angles would be any angles that are not alternate interior or not corresponding or not alternate exterior angles. So remember, the word supplementary means adds to 180 degrees. These would be the pair of angles that add to 180 degrees. Angle A, if you added it with angle G, it would add up to 180 degrees. Okay, notice angle A is on, when I look at the transversal, A and G are both on the same side of the transversal, but A and G are on the outside of the parallel lines. Okay, and that would mean B and H would also be considered supplementary. So that means angle B plus angle H would be add up together to equal 180 degrees. Okay, so if they're on the same side of the transversal, but they're both on the exterior of the parallel lines, then that makes them supplementary, adding up to 180. The same thing would be if you take angle A, which is on the exterior of the parallel lines, and if you added it with angle F, those two angles would add up. They would be supplementary. They would add up to 180. B and E, angle B and angle E would add up to 180 as well. Now, these don't have any special name other than the fact that they are supplementary. But notice in the second two cases, angle A plus angle F and angle B plus angle E, you have one angle on the exterior, A. You have another angle on the interior, F, but they are on different sides of the transversal. Same with B on the exterior, E on the interior. Okay, so that would be the idea of recognizing angles that add up to 180 degrees when you have a transversal. Okay, moving on to the last one, similar figures, solving proportions. So what we're going to be doing in this one is we're going to be recognizing that shapes are similar to one another, and then we're going to be solving proportions with those similar shapes. So let's just take a look at maybe a shape that looks like this right here. This really doesn't have a name other than the fact that it's a 1, 2, 3, 4, 5, 6-sided shape. So this is a weird looking hexagon. Remember, hexagon means 6. And then let's say I have a much larger version of that hexagon over here. And these two shapes are similar to one another. So that squiggle right there, remember, is the word or is the symbol for the word similar. Now, let's say in the smaller hexagon, the left side, the left vertical side is X, the bottom side is 12, and the small part of the top of this is 9. And then let's say in the big hexagon, this part right here is 27. The left vertical side is 22. And then the bottom is 30. Okay, so what we're going to do is because these shapes are similar, we are going to write a proportion. Okay, so what a proportion means is that we're going to compare sides. So if you can see the side in the small shape, which is X, it corresponds with the side in the big shape, which is 22. So that creates the ratio X over 22. Then if you notice in the small shape, this top part is 9, but in the big shape, that top part with corresponds with it doesn't have a value. So I cannot create another ratio, because what I need to do is, in order to make a proportion, I need two ratios. Remember, ratio is also known as a fraction. Now, if you notice in the small shape, the bottom is 12, and in the big shape, the bottom is 30. And so that means those two sides correspond with each other. So that creates the ratio 12 over 30. And the idea is that when shapes are similar, it means their ratios are equal. And then this equation right here, x over 22, is equal to 12 over 30, is what is known as a proportion. And the way that you solve proportions is you use the strategy of cross multiplying. So we're going to multiply the x with the 30, and we're going to write down what that result is, which is 30x. And then we're going to multiply the 22 with the 12, and we're going to write down the result of what that is, which is, and I'm using a calculator off screen here, 22 multiplied with 12 is 264. And then whenever you cross multiply a proportion, the two results are equal to each other. And then we would divide 264 by 30 to find the value of x, and thus solve the proportion. 8.8. 264 divided by 30 is 8.8. So that is what x is, okay? So there's an example of setting up proportions when the shapes are similar in order to solve for a missing value like x. Okay, take down all these notes, be accurate, be thorough, don't miss anything.